Welcome to EDU World Space.
Okay, we have the following molecule that we're analyzing with DEPT 135. It's a dibromo benzene. And the question is, how many signals do we expect? Which, to put it another way, is how many unique carbons or indistinguishable or chemically unequivalent carbons are there in this molecule? And the trick to this is that this molecule is symmetric. I'm going to draw this line through the molecule. We'll notice that this carbon is indistinguishable from that carbon, right? We could flip the molecule over and you wouldn't know which carbon was on the left and which was on the right. That is, they are carbons that are in the exact same chemical environment is another way to think of that. They're both carbons that are attached to a bromine that neighbor a carbon that's attached to a bromine that neighbor a carbon that's not attached to it. And so, if you go around in the circle, you realize every connection that's true for this carbon is also true for that carbon, right? They're equivalent chemically. And that's because of the symmetry of the molecule, which I've displayed by drawing a line through the molecule to display that symmetry. So given the symmetric nature of the molecule, let's label the carbons that are the same, right? We know these two are the same. Let's call them both A. And then it follows that these two would also be the same, right? They're indistinguishable from each other. Right? And then finally, these two will be the same, right? Indistinguishable from each other again. Right? So we should expect 3 signals. That's going to be true for CNMR. It's going to be true for DEPT 135, which is just a specific type of CNMR. But nevertheless, we'll get 3 structures.